Hello everyone, welcome to this lecture video. In this video, we're going to discuss about the different kinds of scheduling algorithm used in CPU scheduling. Let's start with the CPU scheduling algorithm. What is in the previous lecture video we have discussed what is scheduling, what is CPU scheduling algorithm. So, what are the why the CPU scheduling needed for a maximum utilization CPU in the operating system. There are many CPU scheduling algorithms for deciding which of the process in the ready queue is to be allocated to the CPU. There are different types of CPU algorithm here. First come first serve is FCFS. First come first serve scheduling is the important CPU scheduling algorithm. Started job first scheduling is JFS is the second kind of CPU scheduling algorithm. Then priority scheduling is the third kind of scheduling algorithm. Then round robin scheduling algorithm is the fourth kind of round robin scheduling is CPU scheduling important things. So here the four types of scheduling we having these kinds of CPU scheduling algorithm. First, let's start with the FCFS. FCFS it is the simplest CPU scheduling algorithm. In this, the process that requires the CPU is allocated to the CPU first. To implement the FCFS, it is easily managed with a FIFO queue. In the like stack and queue, we have discussed what is FIFO and LIFO queue. It follows FCFS first come first serve follows a FIFO queue. Here the request the CPU first allocated to the CPU first. In the there are plenty of processes in the queue. The first process which process requesting the CPU, that first process will be allocated to the CPU first. The implementation of FCFS is easily managed with the FIFO. So here first come first serve scheduling plays important role here. So in this FIFO, let's start with an example. There are 3, 4, 5, 6, 7, 8 process. The first number P1 will be a 3, P2 will be a 4, P4 will be a 5, P5 will be a 6, 7, 8. Similarly, NQ and DQ. The 2 is the first process. We are going to complete the process at the first come first serve. 2 will be the first in the queue, so it will be the process will be allocated to the CPU very first. Then next 3, then similarly 4, 5 until 8 will be come. So here DQ and NQ we already studied about the basic concept in the data structures. The same FIFO queue principles applied for FCFS scheduling. So in this process enters the ready queue onto the tail queue. When the CPU is free, the process at the head of the queue will be allocated. When the whenever it will check whether the CPU is free or busy with some other process, it find it will be free, then the head of the queue will be allocated to the FCFS scheduling. Here the consider a set of process. Let's have an example to better understanding for the FCFS scheduling. Consider the following set of process arrives at a time 0 with the length of CPU burst time in the given milliseconds. So burst time and P1, P2, P3 will be a process P1. Burst time will be 24, 3 and 3. So for above chart, have to draw the Gantt chart illustrating process execution for all scheduling. Find the turnaround time and find the waiting time for the above process. So the arrival time will be starts with the 0, then followed with the milliseconds. Every time we are given the units as milliseconds. So here the Gantt chart we have to draw. Before calculating Gantt chart, we have to know what is Gantt chart. It is a bar chart that illustrates the process schedule, including the start and finish times of each participating process. So Gantt chart. Then waiting time we have the time is the sum of time period spent for the waiting time in the ready queue. So how much time spending in the ready queue? So some of the time period spending the waiting the ready queue will be called as waiting time. Then we have the turnaround time. Turnaround time is the sum of the period spent waiting to get into memory, waiting the ready queue, executing on the CPU and doing input output. So there is a turnaround time. So next is the process FCFS. We have the example here. Let's start with the FCFS scheduling. In the example, consider P1, P2, P3, burst time of 24, 22, 3 and 3. So P1 arrives at the 24, and P2 arrives at the 3 burst time. So P3 will have the burst time of 3. So waiting time, we have to calculate waiting time and turnaround time. So we can look at the scan chart here. P1 will be 0 started with up to 24. Then P3 will be P2 will be started in the 27. 24. The arrival time of P1 will be 0. Arrival time of P2 will be a 24. The arrival time of P2 will be a P3 will be a 27. So according to this, FCFS scheduling will be worked. We can continue this in the next lecture video. Thanks for watching. I hope you all understand the CPU scheduling, first FCFS scheduling algorithm concepts. Thank you.